really what you want to do. And so what you want to do is you want to follow what we call the order of work. And when we have this order of work, there's, sorry. When we follow this order of work, there's a few things we need to follow. The first thing we want to do is we want to identify terms. Okay, so we want to identify our terms. So just looking at A, can you guys tell me how many terms are there in our question A over there? Four terms. Um, Yes. Okay, so those of you who are saying four terms, I see why you're saying four. And you're not wrong. I think you would be saying four because this is one term, this is another term, and I'm assuming you're counting your fraction as two terms because of this. So you're counting each one of those as one term. So you're not wrong because we can split our fraction up. We can split our fraction up to be two terms. So you're not wrong there. But when we're looking at it just in its entirety, just because this is one big fraction, a fraction kind of also works like a bracket in that everything that's in that fraction, we just count it all as one term. Because remember, it's this whole thing on the top is being divided by negative x. So it's all grouped together. It's all really one term. So yes, it would be three terms. And so the first thing you want to do is identify your terms, as you see that I've done here. And so let's maybe use a different color for the different terms. And then once you have identified what your terms are, the next thing you want to do is you want to simplify each term as far as possible. But now remember, you are doing an expression. And when we do expressions, we do want our expression to have a flow to it. So I'm going to simplify all of my expressions at the same time, but it needs to make sense. My steps need to flow from one step into the next. And so let's see how we're going to do that. The first thing I'm going to do is I'm going to deal with this first term over here, which is my fraction. Now, what I want you guys to know is that when there's fractions, there's two things that we can do. Either I can split my fraction up, which I showed you guys in the last lesson at the end of the lesson. Either I can split my fraction up into two terms. So I could go and I could say negative 3x squared over negative x. So I could do that. And then I could make this minus 2x squared over negative x. I could do that, but I'm not going to. And why am I not going to? Because there's an easier way. When I see that I have a fraction, and in my fraction, either in the numerator or the denominator, there are like terms that I can add. It's easier for me to simplify that way. So to simplify my first term, what am I going to do? Well, I can see in my numerator, I can add like terms. And how am I going to do that? Well, if I draw a number line here super quickly, and then I make this, we're starting at -3. So I'm going to make this 0. This would be -1, -2, -3. This is where we are starting. Okay. If we start over there, and what do I want to do? I'm starting at -3, and I'm minusing 2. Remember now, when I minus on a number line, which direction do I move in? I move to the left. And so because I move to the left, I'm going to jump to the left twice. And -3 minus 2 is going to give me minus 5. But minus 5 what? It's going to give me negative 5x squared, simply because I was dealing with like terms in my numerator. So when there's no like terms, then my next course of action would have been to split it, to split my fraction, to deal with it separately. But because I could add the like terms in my numerator, I'm not going to do that. Okay, so now I've simplified my numerator, and that is negative 5x squared, and I'm left with negative x at the bottom. So that's my first step that I've taken to simplify that first term. Let's now go and simplify the next term as far as I can. For looking at the second term, can you guys tell me, how am I going to simplify? What's the first step I'm going to take to simplify my pink term? Anybody? Brackets? Yes. What about the brackets, Anya? I'm looking for a specific word. It's basically what our entire lesson was about on Tuesday. Thank you, Uma. I am going to distribute. And now, when we have something like this where there are brackets, our first course of action is to say, are there like terms in my brackets? If there's like terms in my brackets, I can simplify within my bracket first. But because in this case, there are no like terms within my bracket, my next step is to distribute. And so that's what I'm going to do over here. And so what I'm going to do is I'm going to go ahead and I'm going to say, well, that would be positive 2xy times x, and then a positive 2xy again times negative 2y. Okay, now what I want you guys to know is you don't have to do this step. You could just go and give me straight the answer. You could do the multiplication in your mind and put the answer down here. But because I feel like we're just starting out with these complicated questions, I am going to write out the separate multiplications first and then give the answer in the next step. But if you feel okay with this distribution concept and you can just put the answer in there to the multiplication, then by all means, that's totally okay. If we now look at my third term that we have over here, is there anything that I can do to simplify this term by itself? Well, when I look at it, it's multiplication. It's saying negative 5 times x squared times y. But although it's multiplication, that means my exponent rules are going to apply. But there's no rule that actually applies here because none of them are the same base. And so because I can't simplify that further, I'm just going to bring my negative 5x squared y. I'm just bringing it down so that it can flow. Remember, my steps have to flow. And so that's my first step done. I've taken my first step to simplify each term. Now, in this next step, I'm going to finalize the simplification of all of my terms. So if we're looking here at this term that I have written in black, what is going to be my next step to simplify that term? What can I do there? Can you guys tell me, how would I simplify negative 5x squared over negative x? Yes, Rory-san.
You're gonna minus the exponent divide, yeah.
Yes, so what would
So
my
it's
answer
gonna
be?
be an invisible one.
Mm-hmm.
And it's gonna be invisible one at the
Yes.
exponent. So it's gonna, I'm not sure if it's gonna minus Mara. The exponent is gonna be 2 minus 1.
It is going to be 2 minus 1. So we have 5x, and it was a square, but we're minusing 1. And that 2 minus 1 is just 1, right?
This man.
But now what about the sign? Do you know what we do with this negative and this negative over here?
And it turns into a positive.
It turns into a positive. Because remember, when we are applying these exponent rules of ours, we always want to use SNV. we first multiply, or in this case, divide our signs. And in this case, it was a negative divided by a negative. And you are so right, Rory-san, it gives us a positive. And then 5, that was part of my numbers. There was nothing I could do with my numbers, so I just wrote it down. And then variables, Rory-san, you were so right in telling me, because it's division, it's the same basis, I can minus exponents. So that was very well done. Thank you, Rory-san.
I'm gonna do the other one.
You can. I just want to see if Lucille has a question first, but keep your hand raised. I'm just gonna speak to Lucille super quick.
Oh, yeah, I do got a question. So for the first term, how did you get like negative 5x squared over negative x?
Okay. So what I had done here for the first term, Lucille, can you see that in our numerator we have like terms?
Yeah.
Remember, with like terms, whenever we're looking for like terms, it's going to have the same variable and the same exponent. So I saw in my numerator, I had like terms. And so what I did was I added those like terms. And that's when I said, well, I have negative 3x squared and it's minus 2x squared. And I did this number line over here. I started at negative 3, I subtracted 2, and then I got negative 5. And that left me with negative 5x squared in my numerator.
Oh, okay. All right, I see.
That makes sense?
Yes.
Okay,
Thank you.
no problem. Thank you. Rory-san, let me get back to you. I just want to erase my circles here super quickly. Okay, yes, Rory-san.
Yes, ma'am. And then, ma'am, the other one, ma'am, you say plus 8. It's gonna be the answer is gonna be 2xy to the times x. It's gonna be 2x to the power 2y.
2y. Can you tell me, how did you get this 2 over here?
Ma'am, there's an invisible one there at x and the other x. So I plus them together.
You plus them together. Why? Because you were applying your exponent rules that say when we are multiplying the same bases, we can keep our base and add our exponent. So you did that beautifully, Rory-san. Next one.
Ma'am, I'm gonna do a plus here again.
You're going to do a plus again.
Yeah.
Okay. I want you to first look at this S and V for me. Multiply your signs. What are your signs here? What are the signs that you're multiplying?
Signs. I don't understand what you mean.
So here, can you see we are multiplying a positive and a negative?
Oh, yeah. Oh, it's gonna be minus.
It's going to be a negative. You are so right. Now multiply your numbers for me.
And it's gonna be 2 times 2 is 4. And then the answer is gonna be 4x y to the power 2.
Y to the power 2, 100%. How did we get this negative 4xy squared? Let me just explain quickly, Rory-san, so give me a second. So we used SNV. Whenever we are doing multiplication or division, we can use the SNV rule. We multiply our signs first, which we did. We said positive times a negative. Then we multiplied our numbers next, which we said 2 times 2, which gave us 4. Then we dealt with our variables. X wasn't really being multiplied by anything. X was just being multiplied with the whole thing itself. So we just carried our X down. There was no rule I could apply there specifically. Then we had our Y times Y, and that we changed into Y squared. How did we do that? We applied our exponent rules, which says when we have multiplication with the same bases, we keep our base and add our exponents. And the exponents here were both these two invisible ones. So I hope that makes sense to everybody. And then, yes, Rory-san, you've done very well so far. Give me the last bit. How did we simplify the green part?
I'm gonna be plus since is the sign is negative and negative.
Where are you now?
And the green side.
Yes, what did you say it was?
I'm gonna say plus.
Okay, why are you making it plus?
Ma'am, write the sign, the negative and negative.
Okay, here it's just negative 5xy. Can you see that we're not really multiplying anything by anything? There's no two different signs that I'm multiplying by. So I can't really simplify this term more, Rory-san. So what I'm going to do is I'm just going to bring it down.
Oh, yeah, my bad. And there's
You see
O
that?
cap. Yeah.
Okay,
Yeah.
cool. Then next step. Now what do we do? So now we've simplified all of our terms, Rory-san. Now what do I do?
Ma'am, I think we try to find the right terms.
100%. And that brings me to my third step. Once you simplify all of your terms, you want to add or subtract your like terms. Okay, Rory-san, tell me which ones are like terms now.
Ma'am, 2x to the power 2y and 5x to the power 2y.
100%. Is there anything that matches this 5x?
No.
Did you say yes?
No.
No. And is there anything that matches my negative 4xy squared?
No.
No. Thank you, Rory-san. Now, let me just explain that as well. Now, what I want you guys to remember is when we are looking for like terms, we're looking for the same, remember, when you are looking for like terms, you look for the same. Oh my God, I cannot write today. Give me a second. You're looking for the same variables with the same exponents. If they don't have the same variables and the same exponents, they're not like terms. So you might be saying to yourself, but ma'am, this is xy as well. Why isn't that a like term? Well, it's not a like term because if you look at the pink highlighted ones, those are x squared y. Here in the green one, it is not x squared. Because it doesn't have that same exponent, they can't be like terms. So that is that. Thank you, Rory-san. And now our last step, we are adding up all of our like terms. Tell me what we're going to do.
Ma'am, we're gonna write this like two like terms.
We're going to?
Write those two like terms down.
Okay, so you want to write the like terms next to each other first.
No. I wanna simplify it from my bad.
Okay. Tell me what it is.
So the answer is gonna be yeah, 2. Yeah.
So we start
And
with
I'm
2.
not
Look
sure.
at my number line, Rory-san. We start with 2 over here. When I minus 5, because remember, I'm dealing with my like terms, so I'm looking at the pink parts. I first have a positive 2, and then I have to minus 5. So let's go to our number line. We start at 2. If I'm minusing, do I go to the left or to the right?
To the left.
To the left. So let's jump 5 times. 1, 2, 3, 4, 5. Where do I end up?
-3.
-3, which leaves me here with -3 and -3 what?
X. -3x. Yeah.
-3x squared y. Remember now, guys, when we're doing like terms, our exponents and our variables don't change. It's only our numbers that are changing. Uma, I see your question. I'll answer it when we're done with this. So that's that. You've added your like terms. Good job, Rory-san. And then the next part, what do we do next?
And I think we leave it alone.
We leave it alone. So, but I can't just leave my last step as this. I have to bring down the other things that I'm leaving alone, right?
Yeah.
There we go. That's that. Does that make sense?
Thank you, ma'am.
Pleasure, Rory-san. You were great. Thank you for helping me. So
Thank
Uma, I
you.
saw that you did ask, can't we simplify it more? I saw that question, but I knew we were still going to simplify more. So yes, where we were at, we could 100% simplify more, but we were taking it one step at a time. And so let me just check. Yeah, okay. How do you study for geometry? The best way, firstly, you have to memorize your rules for geometry. The next thing is practice, practice, practice. When you start with geometry, it can be very difficult to picture the rules, because they give you all these lines and it's like you're just looking at random lines. The more you practice, the more you start to see the rules when you look at a picture. So that's my only advice to practice geometry. It's a lot and lots and lots of practice. So I hope everybody is taking their screenshots if they needed to at this point. Yeah, I'm gonna move on now from this to another one, and then we're gonna move into a brain break. Yes. So, and again, whenever I make space for myself to write, my numbering gets all out of whack. So don't worry about that. Tell me, guys, how many terms do we have in this expression? Four terms. 3, 4. Well, I'm gonna tell you guys it's 3. Why is it 3? Well, in this case, I can't actually split my fraction. I cannot split my fraction because it's multiplication right now. I know there's minuses in the brackets, but remember we ignore whatever's inside brackets. Right now, this is a multiplication at the top. If I have something like 2 times 3 over 6, I can't change this to 2 over 6 times 3 over 6. It's not going to give me the same answer, okay? So I can't split up this multiplication right now of my fractions. So right now, we have 3 terms. What are my 3 terms? Well, this is my first term. My brackets are my next term. And we have our lonely little 3x over there. That's my last term. And Uma is on the money. He's saying distribute the 3xy into my brackets. Remember, what are my 3 steps? I want to identify, oh gosh. I want to identify terms. Okay. Then I want to simplify terms. And then once all my terms are simplified, then I want to plus or minus like terms. So if I go ahead and I start to simplify my first term, 100%, I can't split it. I can't split this fraction, and I've already showed you guys why I can't split it. So what I'm going to do is I'm going to do my distribution of my number outside the brackets into the brackets, which means this is going to get multiplied and this is going to get multiplied. And I don't want to waste steps over here. So let us do our multiplication on the side here. We're going to say 3xy multiplied by negative 4x. And then we also are going to have 3xy multiplied by negative 2x. So I see Alia asking me if her answer is correct, I think. Let's go ahead and let's see. And also what I'm seeing is that we had like terms in our bracket. So we could have done this 2 ways actually. We could first simplify inside our bracket and then multiply, or we can do distribution. I think actually now that Alia has mentioned it, I don't actually know if that's what Alia was saying. Let me just check. In the bracket, 4x times 2x squared plus. I'm not sure what you're asking. So please maybe let's raise our hand to ask about that. So what I'm going to do over here is I am going to simplify inside my bracket. Inside my bracket, so I'm not going to do distribution anymore because that's going to take me long. That's a lot of multiplication. What I've seen now is I have x and x inside my bracket, which I can simplify on the side over here. Negative 4x minus 2x. Well, if I do a number line super quickly, boom, bam, done. And I start with negative 4, so I'm going to make this 0. It's going to be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. I'm going to start at, okay, let's make this negative 7. I'm going to start at negative 4. I start at negative 4, and then I have to minus 2. Well, that's going to give me 1, 2. That is going to give me negative 6x. And so what's actually going to happen over here is I'm going to have 3xy multiplied by negative 6x. And do you see how now I only have one multiplication sum? Whereas if I did distribution, I would have had two multiplication sums. So you could have gone the distribution way. It would have just taken you a little bit longer, but that's okay. That's fine. That is fine. Uma, if you are taught to distribute first, then 100% go ahead and do that. This way is not wrong at all. It's the same thing. We're just doing it a little bit faster. Alia, if you did raise your hand, you would have to speak and explain to me what you were asking, because I'm not sure from your message what it was that you were asking. But I have answered, I've sort of simplified that bracket a little bit. So if you're up to speed now, then, if you don't want to speak, you don't have to, if you understand. Yes, Uma, you would 100% end up with the same answer. It's the exact same thing. Like I said, this is just a little bit of a shorter way. And so to do this multiplication, now I'm going to do my multiplication. I'm doing multiplication, so I want to apply SNV. When I multiply my signs, it's a positive times a negative. So I'm going to be left with a negative. If I multiply my numbers, it's 3 times 6, which gives me 18. And if I multiply my variables, well, it's x times y times x, which is really what it is. It's xy times x. I can group my x's to make it x times y. X times x is going to give me x squared times y. I can just bring it down. And that is going to give me x squared y. So I hope you're seeing how I have simplified my numerator. I kind of multiply 3xy with negative 6x, but is it wrong? No, that's not wrong. That's exactly what I've just done. I've multiplied 3xy times negative 6x. The full simplified expression is, Liafa will have to wait and see. Uma, yes, I did say we'll end up with the same answer. You can do it the other way, and you'll see that we end up with the exact same answer. Oh, Alia, sorry, that was my misunderstanding. I was not understanding that. Okay, you were asking about the second bracket. Yes, Itandile.
Good afternoon, ma'am.
Afternoon.
Ma'am, I'm asking for the second bracket now. Ma'am, for 2x to the power of 2, ma'am, minus 2x to the power of 9. Ma'am, can your x end up being x to the power of 3?
No, because remember here, what is my operation? My operation is subtraction. I can't do exponent rules when I have subtraction. I can only do exponent rules when I have multiplication or division.
Yes, ma'am.
So within the bracket, no, I can't change it. But when I do this distribution, then yes, then I'll do multiplication and then my variables will change. I hope that makes sense, Itandile.
Yes, it does, ma'am.
Okay, cool. So back to my first term, I've now simplified my numerator. If you don't understand how I've simplified my numerator, please let me know so we can talk about it. For now, that's all I'm going to do in that step. I've simplified my numerator. Moving on to my pink term, I see in my brackets, I do not have like terms, so I can't simplify my brackets itself. The next thing I go and do is I distribute. And again, let's start to now save ourselves some time and not do extra steps. So let's do this multiplication in my mind. In my mind, I'm saying it's negative 4x multiplied by 2x squared. And that is going to give me, let's multiply my signs first. Well, it's a negative times a positive. So that is going to give me a negative answer over there. Let's multiply my numbers. It's 4 times 2, so that's going to give me 8. And let's multiply my variables. Well, it's x times x squared. Apply my exponent rules, add my exponents. I get x cubed. Okay, let's go to the next bit. My next bit is still negative 4x multiplied by negative 3xy. Let's apply SNV in our mind. Signs first. It's a negative times a negative, which is going to give me a positive answer. Let's multiply my numbers next. 4 times 3 is going to give me 12. Let's multiply my variables next. It's x times y, which is basically the same thing as what we had there. It's going to be x squared times y, which is just x squared y. And so this is going to be positive 12 x squared y over there. That's me. I've now done my distribution in my second term. Let's look at my third term. Is there anything I can simplify in my third term? No, not really. So I just bring it down into my step. I hope that is making sense for everybody. Let's go now to my next step. Let me do this final simplification of my fraction. So we had 18x squared y divided by negative 6. Okay. Let's do signs first. It's a positive divided by a negative, which is going to give me a negative answer. It is 18 divided by 6, which is going to give me 3. And nothing for me to do with my variables, x squared y. Okay, and then I can just bring my negative 8x cubed down, 12x squared y, and then positive 3x. Now that I've done that, I can add and subtract like terms. So can you guys tell me, are there like terms in my step, this last step that I've got here? Are there like terms for me to add and subtract? I made a mistake. Where did I make a mistake? 8x cubed positive 12. Negative 3x squared y. Oh, I think earlier you were telling me my like terms. Itandile, I did see you said I made a mistake. It is not negative 18. It's not negative 18 anymore. Oh, you're talking about from here. You are so correct. This was a negative 18. Thank you, Itandile, for that. And so if we see now what's happened there, now it's a negative divided by a negative. So that's a positive. But Alia, you are still correct in that this and this are like terms. And those are what I can add and subtract. So if you're confused now about this mistake that I made, that Itandile has pointed out very nicely, just let me know and I'll go back and re-explain it. But now that we've got that, I see, okay, let me add my like terms. I have positive 3xy squared and positive 12. Remember, when I add my like terms, my exponents and variables don't change. So I can almost first write it in here, x squared y. And Alia is very correct. Positive 3 plus 12 is going to give me 15x squared y. And then I can write in the rest of my terms that I cannot simplify. So that is that for this question. Quite a lot that we dealt with in this question, but I hope that it makes sense and you can see now what we talk about when we talk about the order of work. You don't just start and willy-nilly start multiplying stuff randomly across terms. No, you simplify each term as far as you can get it. Obviously, to do that, you have to know what are terms, okay? So you have to identify your terms. You then simplify each term, and then once each term is simplified, you can add and subtract your like terms. So I see Shady is telling me he is 100% okay. And I don't see any questions, so that means we move into our brain break. We don't have much time, so it was a lot of work. But once you start doing these questions, all of these things that I've done on the side, all of the multiplication I've done in the side, you'll be able to do it like super fast in your brain. So if we now move on to our brain break, I was saying we don't have much time, so I'm gonna take 2 hands per thing, per per picture. Just so we can save time. Yes, Liacho, I hope you feel better now because I ignored you last time. So now you get to answer.
Yes,
Oh,
ma'am, I do feel better, ma'am. Hey, ma'am, this one, ma'am, is quite hard, ma'am. I don't know. Actually, ma'am, I don't even know which one I'll get rid of. Maybe earbuds. I'll get rid of earbuds because I hardly have wax.
Yeah, true, but when you do, then what? You know.
Right, then yeah. I don't know, ma'am.
Honestly, I've seen people clean their ears with weird things. Let me be honest. So yeah, I suppose getting rid of an earbud makes sense.
Yeah, makes sense. Yes,
Thanks,
ma'am.
Liacho.
Thanks, ma'am.
Yes, Itandile.
Ma'am, I'll get rid of nothing because these are my hygiene stuff. I need them. Get rid of nothing. Probably the earbuds, probably because like my ears are very sensitive, so the earbuds hurt my ears. So yeah, they even use pencils as like wax cleaners. So yeah, I'm gonna get
Yeah.
rid of the earbuds.
Okay, I see that. Yeah, okay, Tandida, you're with Liacho. I don't know. I'm not sure what I would do. Maybe I might give up a hairbrush, but that says, it says a lot about me that I don't really care what my hair looks like. Um, but yeah, I don't know either. I know I make these questions, but I don't think about them when I make them because they're so hard. I just I just don't think about it. Lulu, I see you've raised your hand. I did say I'm taking 2 hands per thingy mabobby, so I'm moving on to the next one. If you still want to answer this one, then you can raise your hand up again. But yeah, we're done with that first one now. Uh-oh. I've sort of lost my arrows. Oh, there we go, found them. There we go. Rory-san, I see your hand. I'm gonna ask Lulu first. Hi, Lulu.
Hello, ma'am.
Hi. What would you get rid of?
Math.
No, that's my subject, Lulu.
Math, ma'am, math, yo.
Okay, fine. Fair enough. Maths is hard. I get it. I get it. I can accept that answer. Thanks, Lulu, for answering. Rory-san, yes.
Ma'am, so ma'am, I wanna offend you like the others, so that will stay. But the one that I want to go, like it must go is life orientation because
I
like
also thought so.
kind of not useless, but also useless.
It is.
I don't
I
know
felt like that in school as well, so I get you.
because they teach us about like how to end relationships, how to make like I don't understand what's that gonna help.
Right? And it's like, we know this. Like, we know this. Why are you telling me?
Yeah,
I know. Yeah, I
because
get that.
you're
I
just
get
gonna
that.
learn. Yeah,
Yeah, Rory-san, I'm with you. I would also get rid of LO. Or I would do PE because PE, now you came from maths. Now you're tired. Now you must go get changed. Then they want you to run around. Now you're sweaty. Now you still have the rest of school. Yeah, so I might also do PE. But between LO and PE, yeah, one of those must go.
Thank you, ma'am.
Thanks, Rorisang, for answering. And then last one, we have movie genres. We have romance, we have action, we have adventure, and we have horror. I saw 3 hands went up. Rorisang was first. Liaho was next. Itandile, I'm sorry, today you are the one who's getting ignored. Liaho, you just made it. Liaho, you
Yes,
just
ma'am.
made it. Rorisang, yes.
Hello, ma'am, again.
Hi
Uh,
again.
ma'am, I'm gonna take down romance because, like, do you know when you watch with your parents and they cover your eyes and then you like, what's going on? So, like, and when I watch it, it's kind of mushy, like, kind of cringe. So, like, romance
Yeah.
can go.
I get that. Yeah, you're right. You're absolutely right. I never thought about that. Like when your parents cover your eyes and then it's awkward and yeah. So you have a good point,
Yeah.
Rorisan. I see why you would say that.
Bye, ma'am, again.
Bye again. Hi, Liako.
Hi, ma'am, once again. So, ma'am, I'm gonna definitely get rid of horror. I do not like horror at
Same.
all, ma'am. Like,
Same.
ma'am, it's just demons on TV. That's all I can tell you.
That's what I said. Like, why are you showing me these demonic things? Like, get it away from me.
Right?
No, no, thank
Right?
you.
Yeah.
Yeah, Liako,
Yeah.
I'm with you on that one. Thank you for agreeing with me there.
Thanks, ma'am. Thanks, ma'am.
A pleasure. Let's see what people were saying in the chat. Love romance. There's no point if you're single to romance. Yeah. Horror is weird for me. I don't know. From these movies, the only one I've watched here is Get Out. It was so creepy. It was like this girl that used to like date people, but then their family used to like take them to their house and like do weird things to them, like put like chips in their brain and make them slaves. And it was weird. It was so scary. I'm like, no, no, no. Yeah. Okay. That was nice. That was a nice brain break. I think we took a good break. I think we have time to answer this fun one, this fun looking one up here and one at the bottom. So I'm gonna go back to this fun one. I think that's enough space for me. And famous question, how many terms are there here, everybody? It's fun, Shady. It's fun. When you know you can beat it, it's fun. That's why it's fun. It's like, ha, you think you're hard, but I'm gonna show you. You know, I'm gonna show you it's not. You're not hard. You're not gonna beat me. 3 terms. Thank you, everybody. 3 terms. What are our 3 terms? In case you didn't know, those are our 3 terms. Okay. Now that we know our 3 terms, let's get to simplifying. Let's get to simplifying. Okay. Let's look at my fraction first. Now, I'm not going to write anything on the side about our simplification. I'm going to talk about it. I'm going to talk about what must go on in your mind when you see something like this. Because for the first one, we did all the writing for all of our working out. But when you're in a test, there's no time for you to be doing all this writing. You need to start being able to work things out in your mind. And when you are applying your multiplication and division rules, you are applying exponent rules, you can always apply your SNV. And that's super, super helpful to help you do stuff in your mind. So if we look at my fraction, the first thing I'm going to see is I can't simplify my numerator or my denominator. There's no like terms for me to add or subtract as yet. So for now, what I'm just going to do is I'm going to go straight into my simplification of the fraction itself. I know a fraction means division, so I'm going to apply SNV. It's a negative divided by a negative, which is going to give me a positive. Let me deal with my numbers next. It's 12 divided by 3, which is going to give me 4. Okay, when I deal with my variables, it's x cubed divided by x, which means I can go x3 minus 2, and then it's y to the power of 4 divided by y to the power of 2, and I also know I can subtract over there. Now, because I know I can subtract, remember, I know now I can subtract my exponents. I don't want to write this out anymore. I'm past that stage. And so this is going to become y squared. Are we all happy? Please give me a thumbs up in the chat if you are happy with how I've simplified my fraction from what it was to this positive 4xy squared. Okay, I see some thumbs up. The other way you could have thought about it is some people like to do the canceling method. But the thing with the canceling method is you can only use it when there's no addition and subtraction in your numerator or denominator. And so here there is no addition and subtraction. Yes, there's minus signs, but it's not being minused from anything. So what I could have done is I could have said, well, 3 goes into itself once. It goes into 12 4 times. I could have said x cancels out here with the x cubed, but there's still 2 x's left up there. My 2 y's at the bottom cancels out with the 4 y's at the top, but there's still 2. There's still 2. I'm seeing a mistake I made. I went x cubed minus 1, and this x cubed minus 1 is squared. And Itandile has just told me that as well. That is squared. So you could use this canceling method that I've just showed you. But remember the canceling method, you couldn't have gone up here, for instance, and started canceling stuff. You can only start canceling stuff when there's only one part in my numerator and one part in my denominator. When there's pluses and minuses, you can't start canceling randomly. Yes, Itandile. You can unmute. I can't find you to unmute, but you can.
Ma'am, I have a question. If your like terms, ma'am, have exponents that are not, but then the variables are the same, is it a like term?
No.
Unlike term.
It's an unlike term. Remember back here, look at x. We have x over here and x over here. But because they didn't have the same exponents, they are not like terms.
Yes, ma'am.
Okay. Thanks for that question, Itandile. Okay, so we're all happy with how I've now simplified my fraction over there. The next thing I'm going to do is I am going to simplify inside my bracket. I'm going to say, well, that's going to be positive xy squared multiplied by negative 4 minus 2 is going to give me negative 6x. Remember, if you don't know how I got that negative 6, draw your number line. Okay, negative 6x. And can I simplify my last term? No, I cannot. So I just bring it down. In my next step, I'm just simplifying my pink. I want to get rid of that multiplication. So I'm just copying everything down. And then I'm going to multiply. Because I'm multiplying, I can apply S N V. Multiply my signs. A positive times a negative gives me a negative. Multiply my numbers. Well, this is 1. So it's just 6 times 1, which is 6. And then my variables, it's x times x, which is going to give me x squared y squared. And then I can bring my green term down, negative xy. Do I have like terms? Yes, I do. X squared y squared, x squared y squared. I can then say 4 minus 6. If we go on our number line, we would have gotten negative 2 x squared y squared. Itandile, I'm not sure exactly your answer, but this is the answer. And then we can bring down our green little bit. And that is that. This is why I say it's fun because it looks super duper hard. But I know I literally do it one step at a time. And then I'm like, it's not that bad. It's not that hard. Super, super easy. So I hope we're all happy here. Are we all happy? Thumbs up, please. I see one reaction of thumbs ups. Any emojis in the chat? It was easy, right? It was easy. Once you start doing it in your mind, you eliminate a lot of steps and then things become easy. Okay, that was that. Thank you, guys. And last one before we close up, I wanted to do this one to show you guys. What if we have something that looks like this first one? Okay. Well, remember we are going to always apply BODMAS firstly. Secondly, we're still doing the same steps. Can you guys tell me how many terms are there in this question? Yes, Itandile.
Ma'am, I think there are, 4 terms.
Let me check for you. I'll tell you. There are 3 terms. I've just put my little brackets around them. Can you see, Itandile, how there are 3 terms?
Yes, ma'am.
So all of this is being multiplied to each other. All of this is being multiplied to each other. And look, there's my minus separating those 2 terms. And then we have my last lonely term at the end. Happy, Itandile?
Yes, ma'am.
Okay. If I simplify this super quickly, look at what's happening. It's y times y, which I can make y squared, times -3, which is just -3y squared. It's very easy to get confused with things like this. But remember, guys, my terms are things that are separated by pluses and minuses. Everything that I've highlighted up here were not separated by pluses and minuses. They were separated by multiplication, which means they were all one term. And then if I simplify the next, I can say y times y again, which is y squared, multiplied by -2, and bring down my little pink guy over here of y squared. I hope you guys are seeing now how easy this one was. And last step for us to close off our night, we have like terms over here, y squared and y squared. -3 minus 2, it's going to leave me with, it is going to leave me with -5 oh, and this also, my last term was also negative. Okay, I have -5y squared plus y squared, and then I can add that like term again. -5 plus y is -4y squared. That is that. I hope you guys see super easy stuff once you know your rules, once you are comfortable applying the rules. And that is that. If anybody wants to take screenshots of these next ones, didn't mean to do that. Okay. Let me go down and please just stay for the quiz link. Yes, Kunal, there is a quiz link. I'm just trying to go down. Okay. I can't. Let me do this. There we go. For people who want to screenshot these questions to do. Yeah, I know everybody is asking me for the quiz. I'm coming. There's questions. Oh, shit. I didn't mean to say that. Act like I didn't say that. I don't have the quiz link, guys. I don't have the quiz link, but you will find it on Google Classroom. So you can wait. If you want to wait, I'm going to go get the quiz link now super quickly. If you want to go, you're more than welcome to go. Goodbye, everybody.
Bye, ma'am.